Hey, I'm Mr. True. In this video, I intend on running through a very large set of examples for you. That's why this video is so long. Of reading some, real-life situations, or at least some just sentences, and converting them into algebraic expressions. Now, these can vary from the ridiculously easy to, this is pretty complex. And depending on your textbook, at this point, just converting from words to expressions might seem like overly easy and not real purposeful or have a real meaning. But this basic idea of taking real language and writing it into a math equation is what algebra is all about. Taking real-life scenarios. Ultimately, of course, we're trying to, no one talks as in X's and Y's. We talk in words, and we find, area for carpet that we're buying for the room or something like that, where we're taking these situations and trying to figure out how to solve this, problem or this real situation. How much does this carpet cost that's in this room? Well, I got to find square footage, and that's length times width, and I got to, blah, blah, blah. So, getting from words to algebra is a really important idea. So let's start off with some pretty easy examples. 3 more than a number. Well, a number. Well, what number? I don't know. Well, that's what a variable is. A variable is a letter that represents an unknown number. So let's just call this a number. Let's just call this, I don't know, b. So 3 more than a number. Well, more than means add, and the more than and the less than, when those two words are together, they also imply that you need to change the order that you see the stuff in the sentence, change the order of the sentence around. In other words, if I've got, $20 and I need 3 more than that, it's going to be 20 plus 3, which is 23. But you might, well, who cares? Like 3 plus 20 is 23 as well. But if I have $20 and I have, for some reason I need less than that, I need 3 less than 20, well, 3 minus 20 is negative 17, and that doesn't make any sense. It's 20 minus 3. When you have these two words together, you need to know more means add, less means subtract, but those two words together means that you need to change the order of the sentence, what you see in the sentence. So a number, this unknown value, needs to come first, and it's less, 3. It's 3 less than this unknown value of b. How about 5 less than twice a, again, unknown value? I don't care what letter you pick. Twice a number is a multiplication of 2. So twice a number is going to be 2b, and then 5, this is more than. Sorry about that. So 5 less than twice a number is take 5 away from it. The quotient. Well, quotient is division. The quotient, I'm dividing. The sum. Sum is addition. So I'm going to add a couple of numbers. I'm going to add 6 and this unknown value. So the quotient is division. The quotient of the sum of x and a number. So it's implying I need to add these two numbers before I do this division. So I'm going to show that as 6 plus an unknown value of b. And I don't really need the parentheses there because a fraction bar acts as a grouping symbol, but for good measure I'm adding them in. So the quotient of the sum of 6 and a number and 3. So it's the quotient of all of this and 3. So it's all of this divided by 3. And there's our third example. The difference. The word difference means subtract. So the subtraction of, the difference of. Product means multiply. So I'm going to take a couple of numbers now again, it's kind of like the third example, and multiply them. I want the difference of the product of an unknown value and 7. So I want to multiply 7 and this unknown value of b, or x or y or whatever you want to call it. So there's the product of 7 and a number. And that's the difference. I want the difference of the product of a number and 4. I want the difference of this and 4. So there's the difference of 7 and numbered 4, 7b minus 4. You're selling CDs. Okay, what is your profit after selling a certain number of discs, an unknown value of discs, for $8 a piece when it costs you $300 to have them produced? Well, to answer this question, you have to understand what profit is. Profit is what you have left after, like a store. You know, a store doesn't get the stuff for free. The store buys stuff. So maybe the store bought something for $50 and then sold it for $60. Well, their profit is the difference between what they sold it for and how much it cost them. So it's just going to be 60 minus 50. So profit is the difference between what you bring in and what something costs you. Now I'm oversimplifying this because stores have electricity and rental and all that other good stuff, but just a simple example of profit. So what's your profit after selling, you know, a certain number of discs at $8 a piece? Well, how are we going to figure out how much you made? Well, if you sold 2 discs, it was 2 times 8, which is $16. If you sold 3 discs, that'd be 3 times 8, or 24. So you're going to figure out how much you're bringing in by doing 8 times the number of discs that you sold. And notice how I said 8 times the number of discs that you sold. I didn't say 8x. That's another reason why people never think they do algebras, because we don't talk in x's and y's. We talk in words. How much did you make? 8 times how many I sold. Great. But I didn't get those for free. It cost me $300. So from what I brought in, I have to subtract, for profit, for the idea of profit, I have to subtract how much those discs cost me in the first place. So I'm selling them at $8 a piece. I sold a certain number of them. I make some money. I subtract how much it cost me to get those discs, and I have profit. So there you go. Bam! Last one on this page. You have 400 minutes a month on a cell phone plan. And for some reason you know that on average you talk 2 hours a week. Write an expression for this. Well, you start with a big clump of minutes and you burn them off as you talk. So we start with 400 minutes, and as we use them, we don't get more minutes available, we get less, which is a subtraction on the available number of minutes left. Well, I'm talking an average of 2 hours a week, but this is in hours, and the problem starts off in minutes. So I've changed my units of measure, and normally in algebra and mathematics, we need all those units to match, and indeed in this example we will as well. So I'm going to take 60 minutes an hour, or 2 times 60, so for the 2 hours a week that I talk, and I want this to be in minutes and not in hours. So I have 400 minus 2 times 60 to convert my hours into minutes, times x, my number of weeks. Maybe I'll just put a W for week. So my final expression for this one is 400 minus 120 times the number of weeks that I've got the phone. Now, what does this mean? If you're if you have a 400-minute plan, that means it's 400 minutes every single month. Well, if we're talking 2 hours a week, or if we're talking 120 minutes a week, 120, 240, 360, I'm adding 240, or I'm adding 120 minutes a week. 120, 240, 360, I think I'm going to run out of minutes, and I don't have a big enough plan. So I'm Mr. Charu. That's a few examples of converting language into algebraic expressions. Let's look at a few more examples. Let's take a look at these 3 examples. The area of a rectangular table that is x inches wide and 3 times as long as it is wide. Make an expression that would describe the area of that table. Well, it's a bit like geometry. It's a rectangle, and I always do pictures. So that means I'm going to do a little sketch here. I've got a rectangular table. I don't know how wide it is, so it's x inches wide, but I do know something about how long it is. However wide it is, its length is going to be 3 times that. And it says write an expression, or I'm intending for you to write the expression of the area of this rectangle. Now I'm not going to find the area because I don't really know how big the table is, but I can write up a little formula or a little expression that will give me the area of this table as soon as somebody tells me how wide they want it. So, area of a rectangle is length times width. My length is 3x. My width is x. And let's not forget, when we multiply like bases, we need to add those exponents. So 3 times x is equal to 3x squared, and area is in square units, so units squared. This is just a notation for the unit of measure. It's not a mathematical process. I'm not going to square anything. It's 3x squared and then it's units squared. So maybe it's like, oh, I don't know, 400 square inches, and that will describe its area. The next example, the measure of the base angles of an isosceles triangle. So I'm pulling out some examples here that are going to require you to use some of your background knowledge. An isosceles triangle is a triangle whose two sides are the same in length. Well, if the two sides are same in length, then the angles, the base angles opposite those sides, must also be equal. Well, that's fine, and I'm not expecting you, we're not going to be able to actually know what the measurement of these base angles are, but I can make an expression to describe their measurements. So we'll have this upper angle be some unknown value of x degrees. Well, how much is left for the base angles? Well, we also have to know that inside a triangle, the three interior angles have to add up to 180 degrees. So if you've taken up a certain number of degrees already, then what's left is 180 degrees minus x. And these two base angles are equal, so they need to share in the number of degrees that are left equally. Well, if I've got $30 and I want to share it equally, I do 30 divided by 2, which is 15. I probably should have said 30 degrees. I take that and divide it by 2 and get 15. So each of the base angles would be 15 degrees. So I'm going to do 180 degrees, the interior sum of a triangle, subtract out this top angle, and divide it by 2, and that is the number of degrees that is going to equal or describe each of these base angles. Alright, so that's getting a little bit complex. We're turning just a statement in English into an algebraic expression. Need to know a little bit of properties about triangles, though, and isosceles triangles. The sum of two even consecutive integers. Even integers, of course, are numbers that can be divided by 2, like 2, 4, 6, 8, 10, 12. I keep just adding by 2. So let my first integer, my first even integer, be just x. And my next even integer is going to be whatever this is plus 2. Now, if I want to find the sum of these two even consecutive integers, I'm going to put a plus sign here and end up with 2x plus 2. Now, you might be thinking, well, how do I know this isn't odd? So, I came up with this example, but usually questions about numbers being even or odd will ultimately say, the sum of two even consecutive integers is, 28. And it's through the solution process or the solving process that you end up seeing that the two answers at the end actually are indeed even or possibly odd, because the odd numbers 1, 3, 5, 7, 9, and so on, they're also separated by values of 2. So this, you might argue that this is a little bit of an incomplete statement, or that this could be even or odd. Really, if you want to verify a number is even, you need to multiply it by 2. So maybe you could say that it's going to be, 2x, so that I'm guaranteed that my unknown value is even, and then add that with the next consecutive even number of 2x plus 2. But I wouldn't focus on memorizing this too much, because usually in an algebraic problem, usually you're doing, when you see this phrase, you're doing an entire equation. And once you're done solving that equation, you'll see that your numbers were either x or even like they stated or odd like they stated. So most of the time when you see even consecutive integers, it's x and then the next one is x plus 2. Okay, let's take a look at a few more examples and we'll call this topic done. Now in these last two examples, they really sound like a full question that you should actually come up with a numerical answer for, but I've given you just enough information that you can set up just an expression, but yet a lot of problem solving skills need to be brought into actually being able to do these problems. Two cars leave the house going in opposite directions. Alright, so here's the house. One goes this way, one goes that way. If one travels twice as fast, hence the arrow that's a little bit longer, if one travels fast as the other, how far apart will they be after 4 hours? It sounds like you should actually know, but it didn't tell you how fast each car was traveling. So we're just going to get an expression. Now, when you talk about problems where there's stuff in motion, that's distance equals rate times time. So there's a certain distance that this car traveled, and there's a certain distance that this car traveled. I'm not going to be able to figure out either one, because I don't know how fast they're going, but, one of these cars I know nothing about. One car travels as fast as the other one. So the car that traveled the farthest, I know at least something about their rate. It was twice as fast. The car that I know nothing about, or truck or boat or whatever, I'm sure not leaving the house from a boat, but at any rate, this distance I know nothing about, except for the distance equals rate times time. So this distance is the rate times the amount of time that was traveled, and I know it's 4 hours, I'll fill that back in a second. This one, though, traveled at twice the speed. So even though I have no idea how fast this car was going, but I do know this car, or boat, or train, or whatever, is twice as fast. So it's 2r instead of 1r. And the amount of time is going to be the same for that car, because it says they both, how far apart are they after 4 hours. So both vehicles, traveled for 4 hours, or maybe you walked. I don't know. At any rate, it's still motion, so it's still distance equals rate times time. How far apart are they? Well, we do know that it was 4 hours. So we have 4r for the person going to the left here, and we have, 2 times r times 4, or 8r for the car traveling in the, or the boat, or I don't know why I keep saying car, but, going in the other direction, twice the speed. How far apart are they? Well, if I go 2 miles this way and 4 miles that way, aren't I 6 miles apart? I want to add those. So I'm going to add these up, and my final answer is 12r. They're 12 times whatever the rate of speed was that maybe ultimately was traveled. If you then go, well, hey, by the way, the slow car was going 30 miles an hour, or the person was riding the bike at 6 miles an hour, the slower one. So with given a little bit more information, we can actually figure out the real distance, but as an expression with an unknown rate of speed, they're 12r units apart. And my last example says that a school sells $3 student tickets and 50 fewer adult tickets. So in this sentence, I actually have not told you how many student tickets are sold. X. And then 50 fewer adult tickets are being sold, or were sold, for $5. So some tickets were sold at $3, some tickets were sold at $5. How much money was collected? Well, that sounds like you should have an actual numerical value, but I never told you how many student tickets were sold. But I can come up with, so I can't actually solve an equation, but I can write an expression to describe what's going on here. If I sell 5 tickets to students, I made $15, right? 3 times 5, 3, 3, 3, 3, 3. Every time I sell a ticket, I get $3. So it's multiplication for your sales, how much you brought in. So for student tickets, we sold, an unknown value of X, but we made $3 a piece. Now, how much money was collected? Well, to that, I'm going to add how much money I made from my adult ticket sales. And my adult ticket sales were $5 a piece. And how many did I sell? I don't know. But I do know that it was 50 fewer than I sold to the students. So I don't need to come up with a whole new brand new letter. It's not going to be like 3x plus 5y, you know, x for the student tickets and y for how many adult tickets we sold, because we know the relationship. Whatever I sold to the students, I sold 50 fewer to the adults. So here you get to see a little bit of play of, you know, why we had all those very, very simple examples at the beginning of this video. This simplifies to 3x plus 5x minus 250, or ultimately, these are like terms, so we're going to get 8x minus 250. I'm Mr. True. Bam! Go do your homework. Write some of those expressions into algebraic expressions.